Thank you for listening to my presentation. My name is Dr. Wu. Today, I briefly introduce our parametric art to everyone, entitled as Reliable Design of the Mechanical System Subject to Repetitive Stress. This new reliability methodology will improve product reliability. I also will provide two cases of study. One case is Hinge kit system in refrigerator. Another case is newly designed compressor system. As seen in the slide, we know that automobile consists of multiple modules: engine, transmission, driver, electric, and body system. Therefore, automobile part has 25,000 pieces. Reliable target is B40 life 12 years. To improve the performance, company will design product module. In the process, if the module has not designed properly, product does not work in field. Therefore, engineers should find design defect by reliability testing. This is a refrigerator. It also consists of the multiple of the module. Therefore, refrigerator part has 3,000 pieces. Reliable target is B20 life 10 years. Generally, product reliability can define as ability of the item to perform the required function under the state, environmental, and operational condition for specified time. Therefore, new product reliability can describe as best of, but if a product follows best of, it will be rejected in the marketplace because it has initial failure rate, higher failure rate, and short lifetime. So, company improve the product design. Best of will change to the straight line. Finally, we can recognize that product reliability can be achieved without design failure in specified lifetime. This slide shows the failure mechanism in the product design. If repetitive load is applied to product structure and there is a design defect, the structure will collapse in lifetime. To prevent it, design fault must be found before the launching product. The issue is how to find them. The solution is reliable testing under the accelerated loading condition. In material such as silicon, the bonding force can be expressed as a sine hyperbolic function and the exponential function. If you take the inverse, we can find the general stress term. The sine hyperbolic function will start linear, m power stress, and exponential because the accelerated testing will be carried out in medium range. The time to failure can be described as a function of the m power stress and temperature. Finally, accelerated factor can be described as a ratio of the stress-temperature difference. The power in mechanical system must be defined as the product of the effort and flow. For mechanical translation, effort is force, flow is velocity. In the same manner, for the mechanical rotation, effort is torque and the flow is angular velocity. So we know that in time of the failure equation, stress comes from effort. Finally, the accelerated factor can be defined as a ratio of the effort and temperature difference. I will explain how to derive the sample size equation. If the product follows the Weibull distribution, the function can be defined as the shape of the parameter and characteristic. If you take the logarithm, we can obtain the Bx life equation. Here, we don't know the characteristic life. As you can see the slide, The catalyst life can be estimated from testing data. Finally, the assessed BX life can be defined of the chi-square distribution, cumulative distribution function, and testing data. To approximate the assessed BX life, we have two approximations. One approximation is a chi-square distribution. Another approximation is cumulative failure. If the composite level is 60%, R is less than 4, the highest distribution will have R plus 1. When the cumulative failure is less than 20%, the Warrior term will be approximated to X. Finally, the approximate BX life equation is rearranged. We can obtain the sample size equation. I will present one case of study. This is a refrigerator and compressor. It consists of many parts. There are design ports in newly designed compressor, but we don't know which parts are. To find the port design of the compressor, it requires new reliability methodology. This is a parametric design schematics. Compressor is designed to increase the pressure from low to high. In design, we don't know how to use customer and environmental conditions. To robustly design each part, we can achieve the goal of the product design. Therefore, we will contain a new reliability methodology. First, failure analysis for return product. Second, parametric art and design modification. Finally, check product achieved reliability target. This is a damaged compressor in field. We found wear due to the lubrication problem in field. It came from the improper design structure. To modify, we should reproduce the faulty design by parametric art and correct them. This is a load analysis for accelerated testing from mass conservation in completed tube and energy balance in the condense and evaporator. We can determine mass flow rate, condense temperature, and evapor temperature. We know that compressor lifetime depends on the stress. It can from the pressure difference due to the condensing temperature and evaporator temperature. I will explain how to calculate the accelerator factor. Accelerator factor depends on the ratio of the pressure difference and the compressor dome temperature. For worst of cases, pressure difference on the compressor is almost 1 megapascal. For accelerated condition, pressure difference is 2 megapascal. Suppose the lambda is 2, accelerated factor is due to pressure is 4. For worst of case, dome temperature is 90 Celsius. For accelerated testing, the dome temperature is 120 Celsius. The calculated factor due to the dome temperature is almost 4. The total accelerated factor is 13. By applying duty cycle, 3 min is open, 4 min is closed. We can search out design failure. I will explain how to calculate the mission cycle. Life target is B1 life 10 years. The accelerated factor is 13. The sample size is 30. The calculated compressor lifetime for 10 years is 87,000 cycles. Finally, if there is no problem, 18,000 cycles, we can guarantee the compressor life target beyond life 10 years. This is a parametric art equipment. It consists of a testing jig. It's a controller. We can proceed parametric art with the equipment. I will explain the result of the first parameter alt. As you can see the picture, the compressor crankshaft lagged 7,000 cycles and 10,000 cycles. It came from severe wear due to the lubrication problem in compressor design. The pattern of the first alt was very similar to that of the field. By parameter alt, we can reproduce the compressor failure in field. The crankshaft wear in first alt came from low lubrication area, low starting RPM, and crankshaft material. Therefore, we can modify the faulty design of the crankshaft. As an action plan, we modified the dimension of the crankshaft. We added new grooves and changed shaft material. By parameter alt, we can collect the failure of the compressed design. In second alt, we also found the crankshaft wear at 80,000 cycles. It came from the interference between crankshaft and the thrust washer due to narrow dimension. Therefore, we redesigned their dimension. By parameter alt, we can modify the faulty design of the crankshaft. This is a summary of the parameter alt. As is seen in table, 3 parameter alt was carried out. In first parameter alt, we found the lubrication problem of the crankshaft. Therefore, we modified design of the crankshaft. In second alt, we also founding of the crankshaft wear. We changed the washer dimension. There is no problem. 80,000 cycle and 20,000 cycle. Compressor achieved the reliable target beyond life 10 years. I will show you another case study. This is a refrigerator and hinge kit system. It consists of many parts: kit cover, oil damper, spring, and hinge kit housing. There are faulty design in hinge kit system, but we don't know which parts are. Therefore, to find them, it requires new reliability methodology. This is a parametric design schematic. Hinge kit system is designed to comfortably close refrigerator door system by pushing by hand. In design, we don't know how to use the customer and environment condition. By robust design each part, we can achieve the goal of the product design. Therefore, new derived methodology consists of as following. First, failure analysis for return product. Second, parameter alt and design modification. Finally, check derived target is achieved. This is the damage of the hinge kit system in failure. We found that there are a lot of cracks on the hinge kit system housing. It came from the fragile structure. By reproducing them by parameter alt, we can collect a faulty design. This is a load analysis for the accelerated testing. Normally, hinge kit system is subject to the door weight only. To increase the momentum of the hinge kit system, we add additional accelerated weight. Because the time to failure is dependent on impact force and controlling, we can carry out accelerated testing. I will explain how to calculate the accelerated factor. For worst of case, the impact force on hinge kit system 1 kilonewton. For accelerated condition, the impact 2.7 kilonewton. Supposing that lambda is 2, the calculated accelerated factor is 6.3. By applying a duty cycle, pi second is open, 4 seconds is closed. You can search out design failure. I will explain how to calculate the mission cycle. Reliability target is set to beyond life 10 years. Sample size is 6. Accelerate factor is 6. The calculated Hinge kit system lifetime is for 10 years is 36,000 cycle. Finally, if there is no crack in 41,000 cycle, we can guarantee that Hinge kit system reliability target is achieved. This is a parameter art equipment. It consists of test equipment and each control. We can proceed the parameter art. I will explain the result of the first parameter art. As you can see the slide, the hinge housing of the hinge kit system collect at 3,000 cycle and 15,000 cycle. The pattern of the first art was very similar to that of field. By parameter art, we can reproduce the portable design of the hinge kit system. I will explain how to improve the design of hinge kit system. Because the hinge kit system failure in first art came from the weak structure. We designed the weak structure of the hinge kit housing. In outside of the hinge kit system, we eliminated notching, gave a round. We also gave a round inside of the hinge kit system. We also gave the reinforced rib on housing and decks. After finishing the first art, we broke down the hinge kit system. We found the oil damp problems. The root cause of the leaked oil damp came from the oil damp ceiling structure. When operating oil damps, oil rings interfere with the Teflon. Finally, oil damps was spilled. Therefore, we modified the ceiling structure as seen in the figures. By parametric art, we could reproduce of the failure of the oil damp. In second art, we also found the failure housing cover of the hinge kit system at 7,000 cycle and 9,000 cycle. The root cause came from the material of the housing cover. When operating hinge kit system, oil damp spot strike housing cover. Finally, housing cover fractured. The material of the housing cover changed from the plastic to aluminum die casting. By parameter art, we can modify the faulty housing cover of the hinge kit system. This is a summary of the parameter art. As seen in table, 3 parameter art were carried out. In first art, we found design failure of the hinge kit system housing and oil damp. In second art, we also found housing cover. As a design failure are collected, there is no problem. 41,000 cycle and 74,000 cycle. This is my book, titled as The Reliable Design of the Mechanical System. It's enabled mechanical and civil engineer to find out the faulty design and achieve the target product reliability. It also suggests all various of the case of study on mechanical system. Present the Daguchi method of alternative experiment methodology. Describe the new parametric art method for derived quantitative test specification. Thank you for listening to my presentation.